All right, this lesson is 5.2. I can find the inverse of linear and power functions and verify that two functions are inverses. So the verify will be the second half of the notes. The inverse would be the first half of the notes. 5.2. An inverse function maps the output back to the original input. To find an inverse function, switch x and y and then solve for y. So this is a little bit of algebra 1, a little bit of trickery at the beginning, but the inverse is not bad. The verifying is probably the worst part of this whole unit, but again, you always end up with x, as we'll find out in a minute here, but it's not overly difficult. Okay, so as the directions stated, we're literally going to switch y and x. So we first have to remember that f of x is just another way of writing y. So I can change that to y equals negative 3x plus 1. So now I'm going to take that direction to heart here. I'm going to actually switch the x and y. So y becomes x becomes y. Now I left every number alone. I literally just made the x a y and the y an x. Okay, and now we're going back to algebra 1. You need to solve for y. So you need to isolate the variable y, get him by itself. So we need to remove everything around it. So I'm going to subtract this 1 from both sides. That leaves me x minus 1, because you can't combine those, equals negative 3y. And the last step would be to divide by that negative 3 on both sides. Those get eliminated, and I end up with y equals, I'm just moving it to the left side, but it's isolated now, the y, and we have x minus 1 over negative 3. Now, another way you could do that is divide everything on the left side by negative 3 individually. And if you set it up this way, just make note that another way this can be written can look like this. Y equals, this would be like a 1 in front of the x, and we have 1x over negative 3. So 1 over 3 x, and then a negative 1 divided by a negative 3 is positive 1 over 3. So either one of these would be correct. This is what we started with, so I'll circle that one as our answer. Now another notation for y, since this was the inverse, would look like this. F to the negative 1 of x equals that negative 1/3 x plus 1/3. So just know that means the inverse when you have f and a negative 1 as the exponent. So any one of those three are correct. Just know on the test, if you see it in that form, you can't say I never showed you. All right, and the second example. Again, I'm changing f of x to y, 2x to the 5th plus 3. Now literally swap out your x and y. X equals 2y to the 5th plus 3. So we need to remove that 3 from both sides. So we're solving for y now. So we have x minus 3 equals 2y to the 5th. And this is going to go back a unit or two here. First, we need to remove that 2. So you divide both sides by 2. All right. So we're now going up here. We have x minus 3 over 2 equals y to the 5th. And remember, how we undo an exponent is by taking that root. So we're going to have to take the 5th root of both sides. Remember, those cancel, leaving us just our y equals, I'm just moving it to the left side, and I don't need to simplify any of that. There isn't anything in there to simplify. So x minus 3 over 2 to the 5th root. And that is the final answer there. And again, it might say, it might look like this. The f to the negative 1 of x equals that. So that is finding an inverse. Now we are going to do the verifying step. And oh, is this fun. All right, rename your answers in example 1, g of x, then verify that f and g are inverse functions for part A and B. So we had f of x equal to negative 3x plus 1. That was given to us. Now g of x, I said rename your answers. So the answer we got, I'm going to rename g of x. And you can use any one of these. I'll use the one that we circled. So x minus 1 over negative 3. Now we have to verify that they are inverses of each other. So by doing that, you see it right here. Functions f and g are inverses of each other if and only if f of g of x equals x, and then you switch them. G of f of x equals x. So basically you plug this one into that one, and then you're going to plug this one into that one for x. So it'll go something like this. Let's start with f of g of x, and then we would do g of f of x. Doesn't matter the order you do it. So g of x is the innermost one. So I need to, it'll go like this. F of, and you can't simplify this, so I'm g of x is that. So I'm going to plug that in, x minus 1 over negative 3, f of that. Okay? So that means this is getting plugged into x in the f function. So we have negative 3, and now this thing is getting plugged in. The nice thing about these is they all just come out to be x, so everything should be able to undo one another. All right, so if you look on the inside, what needs to happen first? We need to multiply these two. Well, the negative 3 and the negative 3 are going to cancel. So that gives you just x minus 1, and then we have this plus 1 on top. And of course, minus 1 and plus 1 cancel, leaving us x. So we verified f of g of x. So it's kind of silly, but it always works itself out. And if it doesn't, then you just did a step out of order. So let's try it the other way. So f of x is, so I'm going to, f of x is negative 3x plus 1. And so that means I'm going to plug, I should not have put that equal sign there. I'm going to plug this in for x in the g function. So right up here. So this thing becomes the x, negative 3x plus 1. And then you have a minus 1 over negative 3. All right, so we need to simplify the top there first. These two cancel. So we get negative 3x over negative 3. And then the negative 3's cancel, leaving you with x. So see, it looks really confusing, but it always should come out to be x. So we just verified that f of g of x equals x and g of f of x equals x. So that was for A. Now we're going to do B. So the same concept. F of x was going up to B over here. 2x to the 5th plus 3. And then g of x, our answer, we got that 5th root, x minus 3 over 2. Like that. So now we're going to plug each one into each other here. All right, so f of g of x, and we're going to do g of f of x. G of f of x is this, 2x to the 5th plus 3. And now I'm going to plug this into g, which is right here. So that thing is getting plugged in for that x there. So we're going to have this 5th root, and that thing, 2x to the 5th plus 3, gets plugged in for x minus 3 over 2. All right, work from inside. The plus 3 and minus 3 cancel. So we get the 5th root, 2x to the 5th over 2. And the 2's will cancel, leaving you the 5th root of x to the 5th. And of course, the 5's and the radical will cancel, leaving you with x, verified. All right, so I started backwards for some reason. So f of g of x, this is going to be f of, that is our g of x, the 5th root x minus 3 over 2. So this thing is now getting plugged into that x. So we have a 2 out front. Now we have this guy, x minus 3 over 2 to the 5th plus 3. All right, the 5th root and 5th power cancel, leaving us 2 times x minus 3 over 2 plus 3. Guess what? The 2's are going to cancel. X minus 3 plus 3, and the 3's cancel, leaving us x. So it worked out again in this case. So that is verifying. Okay, don't worry about the graphing and the inverse and all that. Just worry about what we just accomplished. So that was 5.2 and the end of this very short unit.